Hey everyone, my name is Trisham Kumar son of Sindrajan. Today I would like to discuss about the regular Falsi method of numerical method, part 1. So let's start now. Okay, these are the topic to discuss about the false position method of regular Falsi in Latin, numerical problem and homework problem. Today I am going to discuss about the false position method or regular Falsi in Latin. So let's start now. Okay, so these are the false position method, also known as regional falsi in method. Let us join the point x1 and x2 by the straight line. The point of intersection of this line with the axis x0 give an improved estimate of the root and is called false position of the root. This point then replace one of the initial guess that has the function value of the same sign as f at 0. The process is repeated with a new value of s1 and s2. Alright, this is the false position method, regular falsi. A numerical way to find the root of an equation like the one shown is x square root plus a x root equal to 0. So that's the numerical way to find the root of an equation like the one shown. Okay, core idea. You start with two guesses x1 and x2 such that f x1 and f x2 have opposite sign. So one positive and one negative. This quarantine the root exist between them. Instead of just guessing randomly, you can draw the straight line between the point like this. So x1 is x1 and so x2 is fx2. So these are the straight line. See where this line crossed at exit. That crossing point is your new estimate of the root. So the formula used to the formula used to this one so x0 is so x1 f x2 minus f2 f x1. So divided by so f is f2 minus f is x1. This gives the intersection point of the straight line with the f x exit. Okay, what happened next? After finding x0, check the sign of f at 0. Okay, replace one of the old point. If f0 have the same sign f, f x1 to replace x1. If same sign as ff2, ff2, so replace to f2. Why? Because you always want one positive and one negative value to keep the root trapped in between. Okay, this diagram is showing exactly how the false position regular falsi method works visually. Let's break it down step by step in a simple way. What you are looking at, the curves your function is fs. Okay, the horizontal line so x and the vertical line fs exit. So s is fs exit. Okay, step 1, start with 2 points. Okay, so x1 is left point. x1 is left point. So x1 is f x1. Okay, so I repeat it. Okay, so left is so x1 is f is x1. Okay, that's it. Okay, so x2 is a right point, x2 is right point. Right, so x2 is f x2. Okay, important. One of these is below the x-axis negative, the other is above the x-axis positive. So the root must be between them. So this one x is negative and these are for positive, so start from 0. Okay, step 2, draw the straight line. You connect h1 at h1 and h2 at f2. That straight line is shown in the diagram, slanted line. Okay, step 3, find where the line hit at exit. That intersection point is h0. Okay, intersection point. This is your new estimate of the root. Step 4. Why this work? Instead of guessing randomly, you are using the shape of the function and making a better approximation. The straight line predicts where the curve might cross the exit. Okay, and the last step, what happened next? Now check, is f0 positive or negative? So f0 is become positive because f0 is positive. Okay, then replace the point that has the same sign as f at 0. So example, if f at 0 is positive, so we need to replace to h2. Or else if f0 is negative, then we need to replace h1. So simple. Okay, you repeat a draw new line and find new 0. Each time h0 move closer to the real root. So that's the simple meaning. I hope you will understand about this diagram. Certainly. Okay, we know that the equation of the line joining the point h1 fh1 and h2 fh2 is given by y minus fh1 divided by fh2 minus fh1, so equal to h minus h1 divided by h2 minus h1. Since the line intersects that the f exit at h0, when h equal to h0, y equal to 0, we have this formula. So we have to add h1 divided by h2 minus fh1 equal to h0 minus h1 divided by h2 minus h1. Okay, h0 minus h1 equal to, so negative at h1, so minus h2 minus h1 divided by fh2 minus fh1. So that's the, so we need to know about this equation to do for formula 1. For example, this is an example of the diagram example of the false position method. Okay, or so these are the formula, this one. So these are the answer, formula of the equation of the false position method. So we need to know about this formula equation. So anyway, so please take note certainly. Okay, that's all for now. So thank you so much, and please don't forget to subscribe to my YouTube channel. So goodbye.